Hello and welcome to a video tutorial on the measures of central tendency. The objectives of this lesson are to find the mean, median, and mode of a set of data, and then find the measures of central tendency of data organized in stem and leaf plot or a frequency distribution table. Many people are familiar with the first objective, so we'll just quickly review that, and then the second objective becomes a little bit more involved, but we'll take a look at that and try and do our best on it. So for a quick review, to find the mean of this set of data that is given here, we can make pretty quick work out of this. Remember that the mean is the average, or sometimes we call it x bar because of the symbol we use for average or mean, the x with the bar over the top. And that is the sum of the values in the set of data. So I add all of these up, and then I divide by the number of values in the set. So in this case, I add them all up, and I divide by 7 because there are 7 values. And that comes out to 147 over 7, or simplified to 21. So the mean of the set of data is 21. That should hopefully be review. If not, there you go. That's how to find the mean, or as we sometimes call it, x bar. Let's get a little bit more involved. Here I've got a data table that shows the selling price of homes in a particular community. Find the mean of the data. Well, we just talked about how to do that. So there's 8 homes, and we're going to use a little bit fancier notation this time. So note that I'm using 8 for the value of the variable n. And then I'm going to use this summation notation. Okay, and let's just make sense out of what's going on here. What is happening is this summation notation is saying I'm adding all the x values up from the first x value to the 8th x value. So I'm adding all of those x values up, and then I'm multiplying it by 1/8, which would be the same as dividing it by 8. So again, all this is doing is adding them up and dividing by the number of values that we have. So that would give me, again, the summation happening here, adding all of those values up, and then multiplying them by 1/8, which is the same as dividing them by 8. It's just a different way of saying the same thing we saw in the previous slide. This is just using summation notation since we have seen some experiences with that. If you're watching this video and haven't seen that before, it's just calculate it the way you saw in the previous slide. Or go for it and try the more involved, eloquent notation of summation notation here. So that comes out to $188,937.50. Okay? Then the median. So to find the median, we want to put the data in order. So I order them from least to greatest. And we find the middle data point. Now this one's tricky. We're noticing this right off the top. We've got 1, 2, 3, 4, 5, 6, 7, 8 data points. So there is no middle. So what I'm going to do is find the mean, or the average of my middle 2 data points. You find the average of those middle 2, add them together, divide by 2, I get $164,500. Okay, so that's our median. The mode. Okay, so which data point happens most often? Well, this is kind of almost a trick question in this case, because all of them happen in the same amount, so there is no mode. If there was a particular data value that happened more than the others, that's what we would call our mode. But in this case, it's that interesting situation, or maybe not interesting depending on how you look at it, where there is no data point that happens more than the others. So we say there is no mode. And so oftentimes we want to say, well, which of these data points or which of these measures of central tendency gives us the best explanation of what's going on? Well, the mean is really affected by this huge value of 394,000. Now looking at the stuff here, everything else is in the 100,000s. This one odd data point here really sticks out like a sore thumb and skews all the data to the high end. So the average is really pulled away from an indicator of what the real middle is, if we want to think of it that way. So maybe not the mean, okay? I'd say the median, the middle value, might be more indicative of what's going on. It is being less, it isn't actually affected at all by this upper value. So in this case, I think that that median would probably be a better indicator of the central tendency. What's a better indicator of that data set? Because the only impact this has, this big value has on there, is that it's just another data set in the top range. Data point, rather, in the top range, sorry. Okay, cool. Let's move on. So we've got a data set here representing the ages of students in a probability and statistics course at a university. So I've got this big data set here. Make a stem and leaf plot of the students' ages. Now, to review how a stem and leaf plot works, we take all of the first or the leftmost place value, in this case it would be the tens, and I record them here as the stems. Okay, so I've got tens happening in here, so like the 19 has got a 10. I've got 20s, 30s, and 40s. The tens place would be my stems. If these data points were in the hundreds, I would put the hundreds there. If they were in the thousands, I'd put the thousands there. And then I put the leaves, the part that comes to the right of that, after. Okay? So for instance, the number 18 would go here. 1 is in the tens place, and 8 would be to the right of that. So this 1, 8 gives me the representation of the data point 18. And then there's another 18 in there, so that is represented again with another 8. And then I've got a 19. They've got 1, 2, 3, 4 of those apparently. And then there's a 20, 2, 0, and actually I've got 1, 2, 3, 4, 5 of those 20s represented here. And that's how this stem and leaf thing is organized, okay? Now, to find the mean of the data, again, add them up, divide by how many there are, so this comes out to 24.03. The median, the middle data set, now this works out really slick when we've got a stem and leaf plot, because I can simply just, I look at how many data points I've got, which in this case, we see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 by 3, 30 data points. So I can count 15 data points in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There. So hopefully, oh, no, hold on. 30. Ha, even number, Severson. All right, so we have to go for the average of 21 and 22, which I've got worked out as 21.5. There we go. All right, so between the 15th and 16th data point, all right, so there is no true middle one, no median, so we had to find the average of the middle too. Find the mode of the data. All right, well, which one happens the most? Well, just glancing at this, we can see this whole big string of zeros in the 20s column, so right away we can tell the mode is 20. That happens more than anything else. A nice feature of the stem and leaf plot. Okay, let's look at another one. Estimate the mean of the scores of 100 students on a statistics test given the following frequency distribution. Okay, so we've talked about class limits and class marks in previous lessons. We've broken this set of data into 1, 2, 3, 4, 5, 6 sets of class limits. And then the class marks, again, remember, are kind of the midpoint of these class limits. So 45 is the midpoint of 40 and 50. All right, and then I've also got here the frequency of how many data points are falling in this class limit. Now there's something else that's really important to note. A nice feature on this table is this F times X column, which is taking the frequency, how many times each of these class limits are generated, and the class marks. So for instance, 21 times 95 is 1,995. This column is going to help us quite a bit with finding the mean, okay? So what we're going to do is I add up how many values I've got all together. So those are all these frequencies added together. and I'm using summation notation again here, sigma notation. And that's 100 events, as we saw here, 100 students. Add all those up, you get 100. And then to find a representation, it's an estimate here now again, because I don't have the exact values, of what would happen if I added all these things together. I take this class mark and multiply it by the frequency of the data's values in the class limit. So the 95 times the 21 is 1995. I'm going to say that would be the sum, approximation of the sum of the values within these class limits is 1995. Likewise, if I added all the data points that fall into this class limit, that would be 2,890, which is generated by 85 times 34. So if I add all those up, we get 7,770. Again, using sigma notation or summation notation. All right, so then simply find the average by what we've always done before. You take the summation of all of the values, which is, this is our approximation of that, and here's the summation, and divide by how many values you have. So I'm going to take this 7,770 and divide by the 100, and we get 77.7, or approximately 78 for the average. Okay, so this f times x, again, is, each of these is the approximation of what I would get if I added all the values in this class limit together. And we find that by multiplying the class mark by how many data points we have within those class limits. Okay, now to move a little bit forward from there, I'm going to tell you right now, this next step gets a little bit hazy. It's a little tricky on how it happens, okay? But we can definitely work our way through it. We are going to estimate the median of the data in the frequency distribution table from this last one. So we're using this same table, but now instead of finding the mean, we're going to approximate the median, okay? So there's 100 scores in the distribution. 50 scores are going to be below the median and 50 scores are above it. Since there are 100 total, only makes sense, there's 50 below, 50 above the median. So if I count up from the bottom to find out where that 50th bracket would be, where's that 50th data set, I count up here, and that 50th data set is going to happen somewhere in this class limit right here. Okay, if I add the values up here, 6, 15, 28, 45, so I'm not quite to that 50th value with this class limit, and then this is going to happen in here because this takes me all the way up into 79 if I include all of these. So it's going to happen in this class limit, okay? At 50th below, 50th above, all right? So going back, the median class is that 80 to 90 range, okay? Now we're going to use some proportions to find what we approximate this down to, a little bit more specific than just the class, okay? And this is how we set it up, all right? Now, I know at the top of that class limit, I've got 79 values from that class limit and below. So from, let me grab my pen tool, from here and below there are 79 values, okay? So that's what this value represents. And from the bottom of that class, here and below, I've got 45 values. So there are a total of 34 values in that class, which we actually see right here, okay? Now, how large is that class? It's 10 units. So from 90 to 80, that's 10 units. Now, what about from the median? Well, from the median value, we know there's 50 below the median, okay? And then from the bottom of the class, again, there's 45. I'm going to use this same value here. There's 45 from the bottom of the class. Now, I don't know how far the median is from the bottom of the class limit, so I'm going to use this variable here, and I don't know what the difference is, okay? Now, what I'm going to do is I'm going to use a proportion to solve this. I say this 34 to 5 is equivalent to the 10 to this x, 10 to the x, okay? I do a little cross product property and I can find x to be 1.47. So this difference from the bottom of the class limit, from the from the median to 80, the difference there is 1.47. So now plugging this x value back in, I can actually find what that median value is. And we get that median value to come out to be approximately 81.5. Again, a rather involved process, and I understand if there's a little bit of confusion. Hopefully, if nothing else, you can follow the algorithm of how this happens, meaning the process, and be successful at approximating the median from a frequency distribution table. All right, good luck, have fun, and pursue and persevere your mathematics. It will pay off.